Now, periodic trends. First, electronegative. Electronegative is a measure of traction an atom has for bowling electrons or how bowling the atom wants to another electron. The higher the electronegative was, more desperate for an electron the atom is. Ionization and energy. This is the amount of energy needed to pull an electron away from the atom in a gaseous state, or tendency of an atom gives to up electrons. Electron affinity. Electron affinity is the ability of an atom to accept an electron. This is a quantitative measure of another energy exchange occurring when an electron is added and a neutral gas atom. Melting point. Increase across a period and decrease down a group of periodic table. This trend is primarily influenced by the strength and atomic bonding with the elements. Metallic character. Decrease as you move across the period is in the periodic table that from the left to right. This occurs as atoms more readily accept electrons to fill a valence shell that lose them to remove the unfilled shell. Metallic character increases as you move down an electron group in the periodic table. Atomic radius. Atomic radius is one fold distance between the nuclei of two atoms on the same element.
The periodic trends. What are a periodic trend? Periodic trends are patterns in elements on the periodic table. Major trends are electronegativity, ionization energy, electron affinity, and atomic radius. The existence of these trends is due to the similarity in atomic structure of the elements in their group families or periods, and because of the periodic nature of elements. The electronegativity is a measure of attraction an atom has for bonding electrons or how badly the atom wants another electron. The higher the electronegativity, how the periodic trends increase or decrease. Atomic radius increase from right to left and from top to bottom of the periodic table. Ionization energy, electron affinity, and electronegativity increase from left to right and from bottom to top. The melting point increase across a period and decrease down a group. The metallic character increase down a group and decrease across a period.
So bonds are chemical processes generated by the attractive interactions between atoms and molecules that stabilize chemical compounds. During this process, atoms can share or give up electrons from their aroma shell to bond and create a new substance or compound. I will explain you the covalent bond. This bond mechanism is based on sharing electrons. They share electrons because they have a similar electronegativity, and this bond is mostly found between nonmetallic elements. It is formed when two atoms come together to obtain stability in the electrons of their last element. There are two types of covalent bonds, polar and nonpolar. In polar bonds, binding electrons are shared unevenly between the two atoms, and there is a partial change on the atoms. And in polar bonds, bonding electrons are shared in equal parts between the two atoms, and there is no charges on the atoms. Now, the electronegativity allows us to predict the type of bond between the elements by comparing the difference between the electronegativity value. A difference between 0 and 0.4 is considered as a nonpolar covalent bond, while a difference greater than 0.5 but less than 1.6 is considered as a polar covalent bond.
Ionic and metallic bonds. They are two different types of chemical bonds that occur between atoms. The ionic bonds, for where one or more electrons are transferred from one atom to another, resulting in the formation of ions. Typically, this occurs between a metal and a non-metal. In an ionic bond, one atom becomes positively charged because it loses electrons, and the other becomes negatively charged because it gains those electrons. The attraction between the oppositely charged ions holds them together in a crystal lattice structure. Ionic compounds tend to have high melting and boiling points because of the strong electrostatic forces between ions. They also conduct electricity when melted or dissolved in water because their ions are free to move. Metallic bonds. Metallic bonds occur between metal atoms. In a metallic bond, the valence electrons of metal atoms are dislocated, meaning they are not associated with any specific atom but instead are free to move through the entire metal lattice. This delocalization creates a sea of electrons surrounding the positively charged metal ions, formed by the metal atom losing their valence electrons. The attraction between the positive metal ions and the delocalized electrons holds the metal atom together in a metallic lattice. Metallic bonds give metals their characteristic properties such as malleability, ductility, and high thermal and electrical conductivity. The mobility of the delocalized electrons allows them carry both heat and electricity efficiently through the metal lattice.
My name is Daniel Casanova, and I'm going to be presenting the topic of intermolecular forces. So, some properties, such as a melting point and boiling points of covalent compounds, can be explained based on the intermolecular forces that hold the molecules together. These forces are weak in general, so it is required to supply less energy for the substance to change their state of aggregation. The forces within an atom holding subatomic particles together are called the Coulomb force of attraction. So, if the atoms come together, intermolecular forces occur within a molecule formed by the atoms, whose force is greater than the force that exists between the molecules called intermolecular forces. So, these forces can be classified into two basic types, the hydrogen bonding and the van der Waals forces. So, summarized, hydrogen bonds are the covalent compounds of HF, HO2, and NH, have the boiling points higher than expected for compounds with hydrogen and elements for the same families. This can be explained by the intermolecular attraction forces, which are intense due to the presence of hydrogen bonds. Hydrogen bonding also occurs in other molecules such as proteins and nucleic acids. Now, with the van der Waals, they are weak attraction that hold electrically neutral molecules together. However, at some point, these molecules present what is called an induced dipole. That is, the molecule acquires a partially positive and a partially negative charge, momentarily causing them to attract each other by the electrostatic effect, generated by the attraction of the positive pole of one molecule with the negative pole of another.